What's up, guys? Welcome to R-Programming with Dare Bear. You know the vibes. Okay, so basically, now before we get into it, let's go over variable declaration. So instead of the equals sign, or instead of the equal sign as we do in Java, we use a little arrow key. That's really cool. So it's like during the school 1738, and you print during the school, and that returned by 1738. Right. Then now if you go really cool during yes check west, and you print really cool during which prints yes check west. So if we say private Twitter and we send a boolean value of true, and we print that, it returns true. However, if we have another variable called public Twitter, and we send the value of no, that isn't a valid value. So if we print it, it results in an error. So if we delete that statement, now we should be able to run the entire program. Nice. Okay, let's get into it now. So here, this is our data set. It's the hottest temperatures of the day in Oakland from February 2019 to January 2020. So this C represents a vector over a collection of data, and these are the individual data points of every day. And we assign that to this variable, right? And in order to aggregate our data further, we assign all these variables with a comma separating each parameter into one called Oakland Hot Temps Both. So now, we can print out the standard deviation of the one in December, the median of December, and the median of December, as well as the mean. We do that for the January one as well, and we do that for the total. We can also print out strings like this is the mean of all the temperatures. But now you guys are probably wondering, what do we do with this data? So with the data, we can make things called plots. These plots are really cool. We can make a box and whisker plot. That basically means that all the data is contained within the barriers, and 50% of the data is contained within these two boxes. We can also make a histogram, and I'm pretty proud of this one. So you have the frequency of the number of times this shows up, as well as the temperature of each category. So each box represents a 2-degree increment. So this would be 50 to 52, 52 to 54, and so on. So by looking at the graph, we can see that the most common temperature is between 72 and 74. With something up above 35, which would be around 36 or 37. So right here is so the code for the histogram is here, right? The color is pink, and this is so main means the title. The X lab is like the label for the X-axis. The Y lab is like the label for the Y-axis, and the border is black. As you can see, the border is black. These are the labels, and the breaks is 20. That's how many categories we want to break our data set into. So now if you scroll down, we have the bar plot. So the bar plot is sideways, because I made it sideways. Because horizontal is equal to true. If not, it'd be a vertical box plot. It's our bar graph. So the color is purple, but it doesn't work for some reason. I'm still trying to figure out why. The Y label is temperature, and the X label is day. So as you can see, we can kind of get the shape of the frequency of everything with the passage of time. So the lowest value represents the first month, which would be around February. And as we go up, it goes like March, April, May, June, July, August. So as you can see, like on like the upward trend, the temperature increases during the summer and decreases back in the winter. So now here's another box plot, right? But this time it is sideways. Yeah, it contains the same one as the other one. However, this one is transparent. Do you guys know why? Because I didn't put color in it. Whoa. So another way to visualize the data is with a scatter plot. So this scatter plot is really weird because it doesn't take in two data sets and like have each one correspond to each other. It takes in one data set and it like increments it per every unit. So with every unit, it plots a point. And with this point, we can also see the general trend of the data. So as it starts in January, it's kind of cold, but it gets warmer towards August and June, the summer months. And then when it goes back down, it gets cold again. So that's how we can model the data as well. So as you can see what I did here, for the dot chart. So the Y label is like the month ascending from February 2019 to January 2020. And the X label is the temperature in Fahrenheit. And the color for each dot is blue to make it pop out more. And the CEX is like the size of it. So if I change that to like 3, it'd be huge, but if I change it to 1, it'd be kind of small. But I also put 0.5 because a lot of my data is a lot of my data is cluttered. So in order to have all of them show up, I need it to be kind of small. Also, here's something I learned not to do. This is a pie chart, right? But imagine having a pie chart with around 350 data points. I honestly don't know what's happening, but it's kind of colorful. So let's show you guys. Let's zoom in for a bit. So as you can see here, this is what not to do with a data set like mine. So if you zoom in, I can't even zoom in that far. But it's okay, guys, because now we know how to code in R, and we kind of know how to make graphs. So this is the strength of R. So you can basically just like make a bunch of graphs, and they can represent your data a lot. But you also have to be able to like explain what the data means too. So for here, like, you can see the general trend. But with things like the histogram, it'd be a bad choice to see if you want to see like how hot it is like month over month.